excited to be joined today by Skye Rubin, a sales manager at Airbus Defense and Space, as well as Joe Peters, a solutions engineer at Exelis Visual Information Solutions. During the discussion today, Skye and Joe will cover how the combination of imagery from Airbus Defense and Space and the advanced ENVI image analysis software from Exelis can be used to increase agricultural efficiencies, including estimating crop yields and water content, identifying stressed plants, combating disease and pests, and more. If you have any questions at any point during the webinar, feel free to use the question area of your GoToWebinar dashboard. Skye and Joe will try to address as many questions as they can at the end of the webinar, and if they don't get to your question, they will follow up with you. And now I'm going to turn things over to our first speaker, Skye Rubin.
Thank you very much for the introduction, Kevin, and thank you everyone for joining this webinar. I first wanted to introduce this slide and just kind of give you a quick overview of Airbus Defense and Space Geo-Intelligence. We are currently one of the leading providers of geospatial information, and some of our core products are satellite imagery, mosaics and DEMS, and then we offer a suite of geospatial solutions to help increase your workflow efficiency and just to make data management a little bit more reliable and a little bit easier. In terms of satellite imagery, we're actually the first company in the world to allow commercial customers to task a specific area of interest at a specific time, and we have over 30 years of experience in terms of programming satellites and basically setting up custom tasking programs that are dedicated to a specific agricultural application or interest. And in terms of the mosaics and DEMS, we really have the largest off-the-shelf suite of large area resolution products, medium resolution products, including spot maps. We have radar mosaics, and then we also have a worldwide elevation product called the World DEM, which we'll mention a little bit later as well. And you can go on to the next slide, please. We've got an overview of our different agricultural applications here. The first being mapping. It may not be quite as popular, or the demand may not be quite as high in the United States as other areas outside the U.S., but there still is a large demand just to come up or to create a really basic land use or land cover type map for crop studies or just for crop assessment. Some of the different things that we provide are growth stage mapping, change detection, crop classification, and mapping crop types or biophysical parameters. In terms of crop management, we have a lot of customers that are really interested to monitor an inventory and to come up with a management plan. Some of them are looking for yield estimation and starting to do work regarding yield and coming up with some of the initial assessments in terms of how to accurately calculate yield using satellite imagery and other data, including crop models and atmospheric weather as well, or atmospheric data as well. In terms of monitoring and reporting, this is one area where the Airbus constellation really works well within the ag vertical. We can track illegal activities, we can track impact assessment, we can really help customers really get a good sense in terms of what's going on with their crops at a specific point in time, whether it's a really tight window. It may be that you're looking for a satellite collection within, say, a 2 or 3 day window, or maybe even a specific day, and our constellation is geared to do exactly that, to collect data and provide it when you need it. And the last thing we have on the slide here is policy reinforcement. Some of our customers outside the U.S. are really looking for help in terms of just initial planning and decision making, and we can come in and use Spot 6 or Spot 7 data, potentially Pléiades data, and help them build a land use, land class map, and really just help them with some of their initial policy planning activities. Next slide, please.
Great, thanks, Skye. I want to just go ahead and talk a minute about the ENVI software stack, which provides commercial off-the-shelf as well as custom solutions for processing and analysis of all sorts of geospatial remotely sensed data. So ENVI itself is the premier solution for working with optical imagery, but we also have products for working with SAR and LiDAR data. And ENVI is also built on a programming language called IDL, which can be used to customize the processing and analysis capabilities of ENVI. So there's actually an API built out around ENVI using IDL, and with that you can handle just about anything you want to do with your data, and I really mean anything. So, and we also have a professional services group that can help get you custom solutions implemented. So if you don't have the in-house expertise, or you just need a little bit of help getting like a couple of the aspects of our software products implemented into your software stack, we can help you out with that. And that's whether you're looking for maybe a unique desktop application, or if you're looking for a cloud-based solution, which we're working pretty heavily on these days. And so we're going to move on right now. We're going to take a look at our first case study. We have some beautiful imagery over Napa Valley that was provided by Airbus for this webinar. So the first, this first kind of case study, I guess if you'll call it that, is I want to take a look at a few things. We're going to talk a little bit about choosing the right spatial resolution for your application. I also want to briefly touch on the pre-processing and analysis capabilities of Airbus data within ENVI. Because this is one of the maybe most important aspects of being able to work with Airbus imagery, and ENVI is the way it handles it so flawlessly. And then we'll also talk a little bit about elevation data and how you can improve analysis using some of the elevation products available through Airbus. And then we'll also start to touch on spectral indices and how we can use spectral indices to extract useful information from our imagery. So, Sky, back to you.
Thanks, Joe. So I think most people on this webinar are probably pretty familiar with Napa. Hopefully some of you have had a great time there. It's really one of the premier wine regions in the world. Right now there's approximately 43,000 acres of planted vineyards, and it's just a world-renowned area in terms of wine quality, and one of the few locations in the earth that can produce a type of wine that maybe could beat the French. But anyway, what we really wanted to do here was help our customers just improve their uncertainty, or actually to reduce the uncertainty, and just to help improve their overall process within the growing season. We've had a few customers come to us looking for weekly collections, some customers looking for bi-monthly collections, others looking for even daily collections within a very specific window. And really the challenge is to be able to collect at a very specific point in time and to deliver that data quickly. So our solution was to utilize Pléiades and then also Spot 6 and 7, and to set up some different collections and do some testing, which we will go through here in the next few slides. You can go on to the next one, please. So the first bullet here, Elevation 1 and Elevation 4 are highly accurate DEMS ideal for agriculture. Both are products that are produced from Airbus DS Pléiades stereo imagery, and both are different elevation products that we will produce on demand. It's kind of like setting up a LiDAR collection. Customers will come to us, provide an area of interest. We will actually utilize our satellites, collect in stereo, and then produce either a 1 meter or a 4 meter post-spacing elevation model. And why is this important for a winery or a vineyard? It really can help them assess the slope, potentially if they're looking to maybe acquire some new lands or just do some site assessment, or really just to create a map for an existing vineyard that has never been accurately mapped in 3D. We can do that remotely using the Pléiades stereo collections, and we can also potentially create elevation models using Spot 6 or Spot 7. So it really comes down to water management, land assessment, and just general planning. Move on to the next slide, please. Here we have an example of a single-day collection from Spot 6. This was on March 13th, and this was just a collection we set up as a speculative test. And I just wanted to put this up to show everyone the large area that can be collected in a single orbit by one of our satellites. This is just Spot 6. If you're to add in Spot 7 data and then data from the two Pléiades satellites, you can really collect a huge amount of California in a single day. We can provide access to information within small parcels. We can collect entire counties in a single pass, for example. So it's really about acquiring data at the right time so our partners can process that type of data and really increase their efficiencies, maybe create an NDVI map or take a look at some biophysical parameters and just get an accurate characterization of the conditions at the right time. You can go on to the next one, please.
All right, thanks, guys. Back to me now. And before we get into a discussion of some of the things that can be done with Airbus imagery in ENVI, I just have a couple of slides that I wanted to show that I hope will give people an idea of the spatial resolution of the imagery that's available. And just as Sky was saying, how you might be looking at something like on a county-wide basis, you might be looking at a local basis within a municipality, or you might even be looking to do some sort of analysis or just get an idea of what's going on in an individual field. And the great thing is that Airbus and their partners can get us imagery from all of these different spatial resolutions. So I want to point out all of these images that we're looking at were provided by Airbus and show off their ability to capture this range of images. So it's important when you work with satellite imagery that the spatial resolution of the imagery fits the needs of the project. So for instance, if you're working on a project at a regional scale, imagery with 22-meter resolution, such as the CMC 2 color infrared image you see on the left, might be appropriate. But projects that occur on a local or per field level, they might require higher resolution, such as available from Spot 6 and 7 or the Pléiades 1A and 1B satellites. So if the resolution doesn't meet the needs of the project, you risk either having results that are too coarse to be of any real benefit to you, or if your resolution is too high, you're doing a lot of unnecessary processing and storing a lot of unnecessary data. So we go on to the next slide here. And this just shows a couple of the high-resolution satellites that Airbus has to offer. So these are Spot and Pléiades images that I'm comparing side by side. So the Spot satellites have a multispectral resolution of 6 meters, which can be pan-sharpened down to 1.5 meters. And then the Pléiades satellites have a multispectral resolution of 2 meters, which can be pan-sharpened down to 50 centimeters, so really high resolution. And so I've kind of zoomed in on this field. You can see what the Pléiades multispectral looks like, and then if you pan-sharpen it, you really get a good idea of the fact that with this Napa area, you can see actually between rows of vines, and you can really see where vegetation health is doing well, and maybe where it's not doing quite as well. What I want to focus on, perhaps from here on out with our case studies, is how we can actually get that information out of the imagery. So one way we can do that is by doing the analysis in ENVI. And so the real beauty of working with Airbus data and ENVI is that ENVI has implemented special readers for opening their imagery. So when an Airbus image is opened in ENVI, all of the associated metadata is read in with it. This includes information about the spectral wavelength of the available bands, the time and date of acquisition, and any gain and offset values that would be required for performing radiometric calibration. So once an image is open in ENVI, you can visualize it. You can look at it in different ways. You can load different band combinations to get a good visualization of it. But you can also perform any sort of pre-processing, including radiometric calibration, atmospheric correction, all those sorts of things. Any geometric corrections that might need to be applied to the imagery can be done within ENVI. And you can do that through our toolbox, which is fully searchable and contains all of our processing algorithms. So that's what I'm showing down here on the bottom is our user interface with all of our algorithms in our toolbox. But the other thing that's really cool that I've been working with a lot is we've made such huge strides in the past couple of years at making batch processing of imagery easier than ever. And so what I mean by that is we've introduced something called an ENVI task, which these ENVI tasks encapsulate an atomic unit of processing work. And this allows us to string together different processes. So for example, in my little snippet of code up here, number one, I want to point out how readable it is, how easy it is to understand what you're trying to do. You're running your calibration, you're running your atmospheric correction, you're performing pan sharpening, all with this little bit of human readable code that is very easy to pick up, even for a non-programmer. So what's great about this is you can chain together workflows very easily. And so if you're just processing one image, maybe you don't want to go through this whole batch process and writing a few lines of code. And maybe you do just want to go through the user interface. But if you happen to be processing multiple images, this batch processing capability is worth getting familiar with. And so why do we do this? Why do we even take the time to do this pre-processing? And I think this is one of the most important things about these agricultural applications that we're talking about. When you get two different images off of either the same satellite or different satellites taken at different times with, perhaps different sun angles and various different parameters that happen to be different, if you're just looking at those images the way they come off the satellite, you're essentially comparing an apple to an orange. because things are different. And these pre-processing steps in ENVI, the radiometric calibration, the atmospheric correction, it allows us to take images that are captured of the same scene, captured at different times. It allows us to use the values that are calculated from the pre-processing to compare information side by side. So effectively, when this pre-processing is complete, you're actually comparing an apple to an apple rather than an apple to an orange. So let's go ahead and take a look at some of the things that can be done. This first slide here of actually getting to see some analysis. This is really just a simple. Let's just kind of get the ball rolling with some ideas that we can accomplish with ENVI. So number one, we've just got a beautiful Pléiades image. It's pan sharpened, so it's 50 centimeter resolution that we're looking at. And we've got it draped over a high-resolution digital elevation model that was provided by Airbus. So we're just simply getting an idea of our scene. This might be really good for site assessment. If you're just looking to buy a property or you're just looking to get an understanding of how your property fits into the overall topography of the area. We can also perform vegetation indices, which I'll be talking about quite extensively throughout the rest of the webinar. So here I've just performed a normalized difference vegetation index, which is one of the more common spectral indices. And then we can also get an idea using the elevation data of the slope of this area. We can also look at other things such as aspect. We can create hill shades and other sorts of things that help us get an idea of it. And so if we wanted to, I didn't do it necessarily for this webinar, but we could take this slope information and we could actually compartmentalize like where the vegetation is healthy and see if the slope or the aspect has any influence on what is going on with the vegetation, which surely it probably does. And so how do we turn this image into actionable information? We'll be focusing quite extensively on these spectral indices. I want to show how we can take information gathered from spectral indices and turn it into actionable information. Spectral indices are great for gaining an understanding of crop health and vitality, and they also allow us to pick things out of a scene that might not be visible in the image alone. So you can see on the left here we have a Pléiades image at 50 centimeter resolution over some vineyards in Napa Valley. And you can see where vegetation might be doing well, where it might not be doing too well. But what vegetation indices allow us to do is actually quantify that information. So we can have an idea of where vegetation is doing very well and where it is not. This allows us to make in-season adjustments. This allows us to say, hey, this is where we're ready to harvest. This is where we need to water. This is where we might have some soil deficiencies. This is where we might be starting to see the encroachment of any sort of pests or weeds and that kind of thing. So the analysis is complete. Now what? And so this is a really important step is yeah, we can perform this analysis, but what do we do with it? Number one, Airbus, as well as Exelis, our company, are business partners with Esri. And so all of our products, whether it's the data products provided by Airbus or it's the software products that I'm speaking to now, they're all very well integrated with Esri products such as ArcMap. So if you are performing this analysis in ENVI, you've done your pre-processing, you've calculated some results, you can actually open your files directly in ArcMap, directly through our interface. So you can send those results into ArcMap. If you're not an Esri user, that's okay. We've got plenty of other options for doing that. Number one, we export to a lot of formats that can be used in other packages, as well as we have the option to export to PowerPoint, Geospatial PDF, or Google Earth. And so what you see here on the right is essentially an image that I marked up using the annotation tools in ENVI. So I've calculated a spectral index. I've seen where my field is not doing so well, where my fields are doing pretty well. And I've shipped this view over to a geospatial PDF. So all of this information, all of my annotation has been preserved. And I can now see that information. I can pass this along to anyone that can open a PDF file for viewing. All right, and now we're going to move on to another area. So we talked a little bit now about Napa Valley and some of the things that we could do with the vineyards. But now I want to move over to the Central Valley, where we're going to use high-resolution imagery off the Pléiades sensors to monitor crop growth in individual fields over time. We're also going to include a little bit of ancillary data with this analysis. This provides geographic context and also gives us some additional information about the fields we're looking at. So we can use this information to make the necessary in-season adjustments due to water deficit, surplus, depleted nutrients, et cetera. We can also detect early onset of disease and pests. And I'm also going to show an example of how we can begin to estimate crop yield. So we're going to get basically try to give ourselves an idea of how maybe this year's crop compares to last, that kind of thing. So go ahead and dive in. So for most of the analysis here, I used a couple of Pléiades images captured over the Central Valley of California. This is being visualized in ENVI using our time series tool, which allows us to scroll through images captured over the same area at different times. So you can see that this first image up top here is a Pléiades image captured on the 10th of August of 2013, right around 1900 hours. And the image on the bottom here is from the 10th of August of 2014, and again, right around 1900 hours. So these images were captured over the same area in the Central Valley of California, approximately 1 year to the day apart, and pretty much down to the minute. So here's our ancillary data. We're going to use a product called Cropscape, which is available from the United States Department of Agriculture. This is a beautiful data layer. It allows us to see actually what's pretty much what is in every crop field across the United States. It has fairly coarse resolution, but it's a really great data product. It can be downloaded for free. You can also view it in a web viewer. Let me jump out of the PowerPoint real quick here. I just want to show. You can also pull this Cropscape layer in the ENVI. So here I've downloaded Cropscape for just the state of California, because that's where we're working. And you can actually see I've got some DMC2 data provided by Airbus through their partner underneath it, and you can see just how well these two data layers line up. So it's products like the DMC2 that allow the USDA to create such a fantastic layer to work with. So get back to my PowerPoint. So here's our Cropscape data layer, and let me show you what I was able to do with that. So what I did is I zoomed into an area of the Central Valley of California, kind of right in the middle of this Central Valley of California, near Chowchilla, California. And I used that crop type layer that we just looked at, and I went ahead and I figured out what was in all of these fields. So we've got some alfalfa, some almonds, some corn. These are actually the three most present agricultural crops in this area. So some of the analysis you'll see later, we're focused on these three crops. And so we're able to now, with the imagery provided by Airbus, extract information, valuable information about what we see in our scene. So this next slide here, I've created a map using ArcMap. The vegetation health was derived from Pléiades imagery provided by Airbus Defense and Space. The imagery was all pre-processed and analyzed using ENVI software. And so we can see I used this vegetation index. It's called Both Savvy, which is the optimized soil adjusted vegetation index. This is a pretty straightforward vegetation index. It works very well when in areas where there's a lot of open soil, because it does a bit of a correction on that, as opposed to standard vegetation index like the NDVI. And so you can see where crop health is doing well, where it's not, where it's growing happily, and where it's really healthy and where it's not. And so this is all valuable information. Here's 2013. Let's go ahead and take a look at that same scene exactly a year later. Here's 2014. And the important thing to know here is that because we've done the calibration, because we made sure that we are using imagery that's been atmospherically corrected, Anything that has the same vegetation health value here for a particular crop, we can really compare side by side to what it looked like in 2013 and 2014. So anything that is, say, 0.85 to 1.15 in the OSAVI index for the same crop is going to be very similar in health and where it is in the growth cycle to how it is in any other image that has been processed in this way. And so this is all great information. It's good to have in a map. But how do we use that to actually get an idea of what our crop yield is going to be like? And so this is a pretty complex question, and there's a lot of additional information that you might need to know. You know, you need to know what is your crop, how long does it take to grow, what is the climate like for a year. There's a lot of ancillary information, historical information about crop yield per acre, that kind of thing. But what we can do with remotely sensed data is get one additional piece to this puzzle, which is just get an idea of a comparison of how things are comparing to the previous year. So what I've done here is I've created a graph that shows from the images that we were just looking at, so from the maps that we were just looking at here, what is the alfalfa content, what is the almond content, and what is the corn content based on their vegetation health throughout the season. So we're able to take a look at, quantify this information from 2013 to 2014. And this will just give us an idea. It's one additional tool that we have, one additional asset for looking at this sort of information. And so clearly we can see here that something is different between 2013 and 2014. 2013 was clearly a better year than 2014 is, whether that's something that could be indicative of drought or the way the fields were planted. It's just one additional piece of information that you have, and so that allows you to kind of predict what your yield is going to be like for the year. And so I've done that here, you know, for this entire scene, and I've done it between, you know, 2013 and 2014. But you could easily do that for, say, just one field, or maybe just the fields that you're interested that are under your domain or your control. So there's a lot of different ways to chop up this analysis and do it on the specific things that are important to you so that you can get the information you need. And the last thing I want to say is the previous slides show us changes in vegetation across a couple of years. Well, one of the beauties of working with Airbus and grabbing their imagery is that they have rapid revisit times. It's very impressive, the holdings that they have. There's also the ability to task satellites directly through their online interface. And so they have these rapid revisit times that allow us to monitor crops throughout a growing season. And this is where you can really get valuable information because you can get information as it's happening in a field and make the adjustments within a single growing season that allow you to make the changes that will help you get your agricultural crop to its strongest vitality. So this is information that you might not otherwise see. So you can see here in these images, they're all captured over that same area of Central California using the Pléiades sensor. You can see we've got some fields here that might have some problems. We can see something that's going on here. We see that same thing here. And again here. So this might be a watering deficit. This might be an infestation of pests. It might be a soil deficiency. But this is something that you could actually take care of within a single growing season if you're able to respond to it, if you have the information that you need to do so. So with that, I think this is a good time to point out, since we're talking about revisit times, I'm going to go ahead and pass it back over to Sky, and we're going to talk about a really interesting crop monitoring project that Airbus has been involved with.
Thank you for that, Joe, and thanks for pointing out some of our capabilities, including the rapid revisit capabilities that Pléiades and Spot provide. So we really wanted to introduce a crop monitoring project that we've been involved with for the past few years. It's for a large government client in the U.S., and we've been collecting the lower 48 basically twice a month, every month during the growing season for the past few years. You can go on to the next slide, please. So our contract was for Airbus DS to deliver moderate resolution satellite imagery using Deimos-1 and also DMC-2 for the lower 48. And the objective, as I just mentioned, was to provide one complete coverage of the U.S. every 2 weeks during the 2014 crop season. We were able to achieve this using both satellites, working with our partners at Deimos and DMC, and actually delivered a total of over 1,600 images. It was 1,621. And you can see here the statistics are pretty impressive in terms of taking a look at the total area collected and then also the cloud cover statistics. But we were able to deliver, on average, 91% cloud-free data over the entire crop season. And if you think about, obviously, the size of the U.S. and the weather conditions we're dealing with during the growing season, it's a pretty challenging project. All of the data was delivered, orthorectified, and sent to the client within 72 hours of acquisition, and our average delivery time for the project was less than 41 hours. And I'm pointing this out because all of this data is commercially available. All of the DMC and Deimos-1 imagery is in our archive, and if you would like to take a look at this, please contact us and we can absolutely help you search our archives and provide more information. And a lot of our customers have been surprised when they look into this data set because frequently, as I'll show you in a future slide, we'll have 15 to 30 images in the archive during the growing season, and this is the least expensive satellite imagery in the commercial market. You can go on to the next slide, please. This is a nice graphic showing the large footprint of DMC-2 and also Deimos-1. They have a really wide swath, as you can see. It's almost as wide as the state of Oklahoma, for example. It's 640 kilometers of width. So using this type of satellites, or these type of satellites, we're able to collect the lower 48 frequently and actually meet these project requirements, which would be something you could not do using a medium resolution or high resolution satellite, just given the footprint and the large area of the United States. Both the satellites are identical. They both have 22-meter resolution. It's very similar to a Landsat 7 type satellite. They have red, green, and near infrared, and those bands align very closely to bands 2, 3, and 4 in Landsat 7. We have a lot of customers that will come to us looking for additional information or additional imagery above and beyond what Landsat can provide. They may not have a budget to pay for a high resolution or a medium resolution data set, but we typically or very frequently will have a lot of available imagery in the archive ready to go, and it's really just a matter of searching their area of interest and providing more information. And if you're looking for imagery for the past 2 years or past 3 years for a certain area, this can really be a great data set to mine into. You can go on to the next slide, please. These are some examples of our collection results. So the first image we have on the top is mosaic we put together for the collection campaign from August 1st through August 15th. You can see some clouds over the Midwest, and if you take a look at it, this data set, though, the majority of it is cloud-free and usable. And the same thing for August 16th through the 31st. I won't go into the exact statistics of cloud cover, but you can see we collected the entire lower 48 and the majority of the data set. The red area is cloud-free and usable. And you can go on to the next slide, please. So 79% of the region was imaged between 16 and 27 times. Once again, all of that is in our archive for the past few years. It's all commercially available. Certain areas around Texas were actually imaged in excess of 35 times, and that was due to a specific project we had set up with a commercial client. If you're looking for a rapid revisit or a high level of temporal revisit from, say, a medium resolution type sensor, please contact us, and we can absolutely talk about potentially setting up a custom monitoring program. And it can range anywhere from 50 centimeter to 22 meter resolution. We really want to be flexible with our agricultural customers and try and set up custom monitoring programs that meet their needs. Move on to the next one, please.
I could probably talk about that, the voucher program here. So a really neat initiative that Exelis and Airbus Defense and Space are offering is this voucher program, which is really great. So any purchase of a new ENVI, ENVI plus IDL, or ENVI Starscape license will allow you a $1,300 or 1,000-pound voucher for Airbus Defense and Space imagery. So this includes 50-centimeter Pléiades imagery, such as I showed off in this webinar. Also 1.5 meter spot 6 or 7 imagery that you also saw in this webinar, or TerraStar X imagery. So lots of great data products that are available. If you want to learn more about the voucher program, visit us at www.excelisbiz.com/Airbus DS. And on our next screen here, I think we're going to have a couple of additional emails for you. So any questions you have about the webinar, we're going to stay online a little bit afterwards. We're going to go ahead and answer what questions we can. But if there's something we don't get to, if there's something maybe a little more specific than we have time for within this framework, give us a shout out at either info@excelisbiz.com or solutions@astrium-geo.com.
Great. Thank you very much, Joe and Sky, for that, those informative presentations. We do have a lot of questions coming in, so we're going to get to those now. As a reminder for attendees on the line, feel free to type in your question in the question box on your GoToWebinar dashboard, and we'll try to have Joe and Sky address as many of those as possible. So it looks like the first question is for Joe, and that is, what pan sharpening technique did you use for the Pléiades imagery of the Napa Valley data?
Hey, so that's actually a great question. ENVI has a lot of different capabilities for performing pan sharpening. I want to say there's definitely more than 5 algorithms. There's probably even more than that. So in the past, I've always used Graham-Schmidt pan sharpening because I was, from what I've read, it was very good for maintaining the multispectral characteristics of an image that would be good for further analysis. But I've actually moved on to using something called NN diffuse. Let's see if I can actually find that by Googling it. So we've got this NN diffuse pan sharpening algorithm. All the information, if you just Google NN diffuse ENVI, it'll pull you into our doc center, which is a really great place for getting this sort of information. And it explains the whole algorithm that's used. This was developed by the Rochester Institute of Technology, or the imaging department over there that we have a pretty close relationship with. And the great thing about this has been implemented as an ENVI task. And all the ENVI tasks that are being developed in our new user interface, they're multi-threaded, so it happens really quickly. So it takes advantage of all the processing capabilities of your computer. So that's what I use.
Great. Thank you, Joe. It looks like the next question may be for Sky. And the question is, what is a general price range for Deimos DMC image data?
Sure, that's a great question, and thanks for whoever asked that one. The price range for Deimos or DMC archive imagery that's older than 3 months is actually 8 cents per square kilometer. It sounds cheap if you're used to buying high resolution or even medium resolution data, but there's a minimum order size of 6,000 square kilometers, and then once again the price per square kilometer is 8 cents, so 0.08. If you wanted to buy a new archive that's been collected within the past 3 months, then the price goes up a little bit, but it's still really inexpensive, and that is 12 cents a square kilometer, and that has the same minimum order size. If you're wanting to set up, set up new acquisitions or set up tasking with either company, with Deimos or DMC, the minimum order size is a little bit larger at 10,000 square kilometers, and the price is 20 cents a square kilometer. That being said, if you're interested in doing something custom with these sensors, I would love to talk to you about it. There is flexibility depending on the volume and just the AOI size you're looking for.
Great, thank you. Looks like another question that came in is probably for Joe. Was the Pléiades imagery of Napa Valley atmospherically corrected before or after using the NN diffuse pan sharpening?
I want to say that I did it. I'd have to look at my processing workflow, but I'm pretty sure that I did the NN diffuse prior to atmospheric correction. I'm not sure that atmospheric correction can be handled with a single band image. So the panchromatic file would not be atmospherically corrected properly unless it was pan sharpened first and then atmospherically corrected. I can find out for sure. For sure what I used was the QAC, which is our quick atmospheric correction, which is part of our atmospheric correction module. So the atmospheric correction module includes Flash, which is a very robust atmospheric correction technique that takes into account all sorts of metadata information about the scene, including the sun angle and the nadir angle, and also whether you're looking at an image over a rural area or an urban area. Whereas the flash module is great. I actually use Quack, which is just an in-scene atmospheric correction technique that is actually pretty quick. So there's also, if you don't have the atmospheric correction module, there's also some things you could do, such as dark pixel subtraction and that kind of thing that are available out of the box with ENVI.
Great. Another question that come in, actually there's a few of them kind of related to this. People are inquiring about getting training for image analysis in general, and then also if there's anything in particular for agriculture, in that market, maybe something that's a custom image analysis training. Joe, if you want to maybe address that.
Yeah, again, I'm going to go ahead and just refer to our webpage. Number one, there's all sorts, if you go to our main webpage, there's all sorts of videos online. We've got blogs that are actually pretty cool that, we talk about all the neat stuff that we're working on and just some things that are kind of higher level things. We've also got this events and training, and this is what I would really want to point out. So all of our training classes, number one, are webinars. You can attend future live webinars, or you can go back and review our previous webinars. So for instance, this will probably be up in a couple of days, and we'll also send links out. And then there's also our classroom training. So if you click on this, you can actually see that we offer classroom training here, or we do on-site training if you've got a number of people that want to take a class. So I would say go ahead and email us at, so here's our schedule. And so you can actually see where and when we'll be offering classes in the future. And also, if you have any questions about that, please feel free to get us at info@exelisbiz.com, and we'll parse that to the right person here. We've got a couple of people that handle our training, and they'll be sure that if we have a class that's available, that we can get you into it.
Great. Another question that's come in is, should the atmospheric correction be applied to both panchromatic images and multispectral images, or just to multispectral ones?
Okay, I think I kind of answered that with the last question. So atmospheric correction, as far as I know, cannot be calculated on a panchromatic band by itself. At least in the tools I've used in ENVI, it requires a multispectral image, so you would have to pan sharpen first. And I should say that, there is some debate whether or not you actually want to pan sharpen an image that you're going to perform further analysis on. Some of these pan sharpening techniques have gotten a lot better at preserving the information in a multispectral file once pan sharpening has been applied to it. But general rule of thumb is sometimes it changes the spectral characteristics when you pan sharpen an image. So for the most accurate spectral results, performing pan sharpening is not necessarily the best technique for further analysis. I did go ahead and do that in this webinar, and I think I got great results, and I trust those results because I use that NN diffuse pan sharpening algorithm, which doesn't change the multispectral characteristics too much, but that's something to keep in mind. And I would say contact our technical support for more information about that, and we also have a bunch of resources online about that.
Great. I have a question that has come in. It looks like, Sky, it's probably for you. I'm just going to read it. I'm not sure that I completely understand the question, but maybe you could answer it better. Someone would like to know when there are going to be future passes of satellites that are collecting images for AOI science or EOS. I think you might be able to see the question, Sky, as well. Do you have any feedback on that?
I'm not sure exactly what they mean by AOI or EOS, but if they would like to contact me directly with my just Ruben at astrium-geo.com, or even the solutions at astrium-geo.com, I definitely would like to try and answer that question directly. I would say that in terms of providing future passes or future collection information, that's something that we will do on a case-by-case basis depending on the project. For a standard tasking order, we're not going to provide every potential attempt, because at this point we'd basically be giving you a date of pretty much 6 or 7 days a week, and we can tell you roughly the time window. But sometimes we'll have clients that are actually in the field, maybe with a spectrometer, or they're trying to actually gather some data at the exact time of the satellite pass. And if we have clients that are trying to do that type of work and are willing to, work with us in terms of signing an NDA and keeping some of that information confidential, then we absolutely can share more information about the future passes. So I'm not sure if I hit on exactly what they were looking for there, but contact me directly and we can talk about it, and I'm sure I can answer the question in the end.
Great. It looks like another question for Joe is, does ENVI support QAC and Flash with Deimos and DMC data? And it looks like kind of the secondary question to that, does it pick up the image metadata that can be used for atmospheric correction?
All right, so that's actually an interesting question because I just got out of a meeting where we were talking about ENVI 5.2 Service Pack 1, which is due at the end of February, beginning of March, somewhere in that time frame. I know quite a bit of work was done to get the Deimos and DMC sensors supported in orthorectification, and I believe that also includes the Flash module. Yeah, so Amanda O'Connor actually said to email her was her response to that question. I would go ahead and maybe do that. So that's amanda.o'connor@excelisphys.com, or email me directly, joe.peters@excelisphys.com, and I can get you a better answer. I know that's either on our backlog or going to be supported at the service pack, but it's something that we're working on, if not supported already.
Great. Another question that's come in is there the possibility that we can have the option to save raster data other than to ship the file option within ENVI?
I'm sorry, I'm not seeing that question. Can you ask it one more time?
Yeah. Is there the possibility that we can have the option to save raster data other than the chip to file option within ENVI?
Yeah, so I'll say a couple of things about that. I'm not exactly sure what you're trying to do, but number one, we do have the chip to file option, which allows you to save that data, and that really is, it's the resolution of your screen, and that's what you're getting when you do the chip to view. But we also have the option to just do, on any image, file save as, and actually save that image into either an ENVI format, whether that's a spatial subset or a spectral subset, as well as into TIFF images, JPEG images, PNG images. So there's a lot of different image outputs that are available that would actually save the full resolution of that image. And I'll also say I actually got this onto the backlog myself because it's something I've been interested in doing, is being able to apply different color stretches, apply different transparencies, different maybe color tables to a single band image, and being able to export the full resolution image with that stretch or that color table applied. And now when you do that, you're obviously changing the pixel values. So you're no longer doing any sort of scientific analysis, but you're saving an image that you might want to present to people, whether that's showing them a scene with the appropriate stretch for visualization, or maybe a color table that highlights the results of your analysis. And so that's on our backlog, and that'll be able to be done in the future. But a lot of that, the file save as stuff is there in ENVI right now.
Great. We'll give folks maybe one more minute to type in some questions. Otherwise, this webinar is going to be recorded, and we are going to send a link out to all the attendees. So I know there's been some questions about that coming in. So you can expect an email coming back, and the link to the recording will be found there. We'll see if there's any additional questions that have come in. Otherwise, we'll let everyone get going.
I'm going to go ahead and answer one other question. Christopher Potter asked a really great question, which is, what methods have you used to validate that your vegetation indices predict actual crop production at less than 5% error, which is what most growers require? It's a great question, and the honest truth is that it hasn't been done for this particular webinar, and that's kind of what was at the root of my statement that, hey, this is what we can do with remote sensing software with Airbus Imagery. There's a lot of additional steps that would be required to make this work in a real-life situation where we're looking for less than 5% error. That's where our professional services group can help you out to address actual needs, actual requirements for specific projects, for specific organizations for specific applications. So we've got a lot of experience doing that with our professional services group, but it requires a lot of historical data, a lot of in-field reconnaissance, so you're actually collecting in-field information that you can use to validate your results. So there's a lot that goes into that. Well, that's not necessarily what I was trying to do with this webinar. That's something that we could do if you were to approach us and approach Airbus as well, and we were to talk that out and see how our professional services group could help you implement that solution for your business.
Great. Another question that just came in. Is it possible to overlay images with the same resolution?
Overlaying images given the same resolution is available. Yeah, so the ENVI interface allows you to actually overlay lots of different, there's a lot of different ways to view images in ENVI. So you can, I'm not sure if that means to like actually seamlessly mosaic them together, which we can do, and then you can also just view them in a lot of different ways. We've got different view windows that can be opened up, or you can actually adjust transparencies, that kind of thing. So I'm not sure if I answered that correctly, but.
Okay. Thank you, Joe. Sky, a question for you that's come in is, relevant to agriculture, is surface energy balance and evapotranspiration, if I'm saying that right, excuse me if I'm butchering it, is there any plan to acquire thermal bands at higher resolution?
You know, that is a really great question, and it's one that I've been asked a few times over the last 2-3 years. And of our newest satellites that we just put up between Spot 6, Spot 7, Pléiades 1A and 1B, none of them have a thermal sensor on them. And it really just comes down to the cost to install and operate a thermal sensor on a spacecraft, and then in terms of, you know, finding a suitable business model that'll pay for that type of sensor. That being said, I think there's some future technology coming from Airbus Defense and Space that I can't go into detail about today, but in the near future we will be able to share, and I think that there'll be some other platforms that we will be able to offer that could potentially offer a thermal sensor, or really could support any type of sensor our customers are looking for, as long as it's under a certain weight class. So something that we can talk more about. If this person wants to contact me directly, I definitely would like to speak with them more about the future of thermal from our side.
Yeah, I want to say kind of the same thing about, there's a couple other questions we had. Someone was asking about Earth observing satellites and planning tools for rapid revisits, as well as examples of correlating yield maps, soil types, soil tests in an area of interest. So I think that's pretty, it seems like a pretty more in-depth, maybe something we should take offline. They're great questions. I'd like to get a little more information about what you're asking, and I can see number one, what we've worked on in the past and what we're also working on in the future for that kind of thing. So the person that asked that, if you want to hit me at my email address, joe.peters@exelisbiz.com, I'd be happy to find out a little bit more and get you some answers.
Great, thank you. Someone asked, how are you able to end up with so few clouds in the imagery that was presented?
I will answer that one. I think it really comes down to our expertise in terms of satellite planning and acquisition, and also in terms of the Spot and Pléiades system. We're uploading a new forecast, a new weather forecast, every 4 to 6 hours, depending on the sensor. So when you're uploading 4 to 6 tasking plans a day, if the weather improves, and we know the weather has improved, we're going to collect. You know, some of the other competitors out there are uploading 1 to 2 tasking plans a day, and if their initial assessment looks like it's going to be cloudy, they may decide not to collect an area. 4 hours later, it may have improved significantly. The area may be cloud-free, and they're not even going to try and attempt it because they don't have a very up-to-date weather forecast. So it really comes from 30-plus years of collection planning and satellite tasking experience, and then just having a really great team of experts in Virginia and also in Toulouse, France, that are programming our satellites on a daily basis and really focused on collecting cloud-free data, or data that's as cloud-free as possible.
Thank you, Sky. Another question that came in is wondering if there is a task to compare multi-temporal off-nadir data, and should the orthorectification be applied after calculating NDVI or before? It's a complicated one.
Yeah, let me, I'm trying to look at that one. If there's a task to compare multi-temporal off-nadir data, should orthorectification be applied after NDVI or before. That's pretty, that gets complex. I think that, when you're comparing multitemporal off-nadir data, there's a lot of things that even the best orthorectification in the world, yes, it'll geometrically correct it to represent the right spots on the ground, the right pixels in the right places. But when you're comparing data from two very different look angles, you're getting a different view of the scene no matter what. And so performing any sort of change detection, if you're trying to do it pixel by pixel, is very difficult. And so I've run into a lot of problems with that myself when processing. It also depends on the area you're looking at. If you're looking at, a very flat field in Oklahoma, you might be all right. If you're looking at, some of the imagery we were looking at today in Napa Valley, where it's a lot of rolling hills, there's a lot of, different characteristics to the topography, it might be a little bit more difficult. That's actually one of the challenges we've seen with, things like UAV data, because there is a lot of, off-nadir data. There's a lot of complexity to working with it. So definitely, though, perform the orthorectification. I would say that's the first step. Get your imagery as geometrically corrected as possible, and then apply your NDVI. And so you can still get a good idea of the characteristics. If you're looking at vegetation health within a field, you can get a good idea of characteristics of what's going on at one time versus another. Where it gets a little bit difficult is when you actually try to perform some sort of change detection, because that really amplifies the differences in geometric accuracy and the differences in the nadir look angle.
Great, Joe. And with that, we're going to wrap up here. So we appreciate everyone's attention on the line, and thank you again, Joe and Sky, for this great webinar presentation. Look for more Airbus and Exelis webinars coming in the future.